Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on incident matrix and its related problems. So first, incidence matrix. So matrix associated with network graphs. So what are the matrix? So first one is the incidence matrix, second one is the fundamental loop matrix, that means tie set matrix, and fundamental cut set matrix. And incidence matrix is represented with A, and fundamental cut set matrix is represented with B, and fundamental cut set matrix is represented with C. Now here it is in the form of matrix. Now this matrix size incidence matrix size means number of nodes in a graph cross number of branches in a graph, and fundamental loop matrix, that number of loops in a graphs. So now here n number of loops L1 L into B number of branches, and here number of cut sets and cross number of branches in the graph. So first I will explain incidence matrix, then after fundamental loop matrix, that means tie set matrix, and fundamental cut set matrix. Now here, what is incidence matrix? Incidence matrix is a matrix which represents graph such that with the help of matrix we can draw the graph. From the incidence matrix we can draw the network graph. And next, so incidence matrix is represented with capital A, and it consists of rows and columns. Here rows represents number of nodes and columns represents number of branches. The rows of the matrix represents number of nodes, this one, this rows number of branches, this one, and the column of the matrix A represents the branches in the number of branches in the network, in the network graph. Next, if there are n number of rows in a given incident matrix, that means the graph consists of n number of nodes, and if there are m number of branches, that means the graph consists of m number of branches. So here this is the graph, suppose. So possible number of nodes 1, 2, 3, 4. 2 or more elements connected to one point is known as a node. Branch means the terminal which is having element which is having two terminals, that is branch. So now here possible number of nodes, here particular node is 4 and branches 1, 2, 3, 4 and 5. Now here 5. So the incident matrix size is 5. So here 4 number of rows and 5 number of branches here. So 4 rows and 1, 2, 3, 4, 5 number of branches. Now here the order of the incident matrix. So the order of the incident matrix is n cross m. Here if there are n number of nodes, 4 number of nodes in a graph, and the incidence matrix have n rows means 4 rows, and m columns means that m column represents the branches. So here m represents the branches, number of branches, and n represents the number of nodes. Now the order of the incidence matrix is n cross m. It is represented with A. So from the incidence matrix we can draw the network graph. So it is represented with capital A, and here that matrix order is n cross m. Here n represents the number of rows, and that the number of nodes, that n indicates rows, and m indicates the number of columns, that means number of branches in the graph. Now reduced incident matrix. So it is also represented with A. In reduced incident matrix means, if suppose in the previous case we have 4 by 5 matrix, 4 rows, 1, 2, 3 and 4. Next 5 number of columns, 1, 2, 3, 4, 5. 4 nodes and 5 branches. Here if any one of the row completely deleted from the matrix, then that matrix is known as reduced incident matrix. So now here this reduced incident matrix can be obtained from the mathematical manipulations, matrix mathematical manipulations. That's matrix in the previous case 4 by 5 n cross m. So if you delete one row, that means n minus 1 m. Here m means this is the m. Now here if you delete one branch here, so only 3 by 5. If you delete one complete row from the incident matrix, that means that is reduced incident matrix. Reduced incident matrix. Now here procedure to find the incident matrix. What are the steps to follow the to find the incident matrix of directed graph? So step 1. So step 1 is first select one node. Select any one of the node at a time of the given directed graph, that means oriented graph, and fill the values of elements of incident matrix corresponding to that node in a row. So that elements may be here 0, 1 and minus 1. So that 0, 1 and minus 1, that this indication I will explain in the next slide, and repeat the same steps for remaining node. For all nodes you have to perform this first step, and for a given directed graph, oriented graph. So now here these are the steps, 2 steps to get the incident matrix. Next, elements of the matrix. Incident matrix. Incident matrix is represented with A. If the matrix with n number of rows are b number of columns, so n number of rows and b number of columns, each entry of matrix is I comma j, and here I is the row, I is the number of row number and j is the column number. Now here this, if suppose this one I am taking 3 by 3 matrix 1 0 1 1 1 0 1 0. Now here this one, so this first one, so here ij, this is the a1 comma 1. So first row, first column, aij, I equals 1 and j equals, and this is the first row, second column 2, and this is the first row, third column I1 3. Here I equals to 1 and j equals to 3. Here a, this 1 indicates I 2 comma 1, a 2 comma 2, a 2 comma 3. Second row, first column, second column and third column, and a 3 comma 1, 3, a 3 comma 2 and a 3 comma 3. Third row, first column, third row, second column, and fourth row, third row, third column. So now in this way we can represent with the help of j. So ia ij equals to 1. So now here jth branch at a node I, so leaves away from the node k, node I or k. Now here the element ij, when I1 indicates living away from the node and minus 1 indicates enters towards the node. This point is most important. Living away from the node means that is plus 1, and living away from the node indicates minus 1, and aij value is 0 indicates that is not associated with the node, that branch is not associated. If branch orientation is living away from the node means that is plus 1, and if it is entering to the node indicates that is entering towards the nodes. Branch orientation is entering towards the node indicates that is minus 1. If the branch is not associated, means the branch is not a part of the node I, that indicates the 0 value. Now here what are the properties? So now algebraic sum of any column, algebraic sum of any column of entry of the incident matrix must be 0. So if you summation, this column summation must be 0. If you take any column, now here the first row column summation, algebraic summation, here elements may be either 1, minus 1 and 0. Now Second property is the determinant of closed loop is 0. If the determinant of closed loop is 0 and the determinant of incident matrix of tree is +1 or -1. So these are the three properties. In this, the most important algebraic sum of any column in the incident matrix, that must be 0. This point is most important. And next thing, so first, problems. So for a given graph, network graph, determine incident matrix. So now here in the previous slide, here these are the three elements you need to fill. So now here this is the network graph. This network graph can be drawn when in the network, when all elements are replaced by line segments and voltage source is replaced by line segment and current source is replaced by open circuit, and name the number, give the numbers for, name the for nodes and branches and assign the directions. Now here for this particular network graph, determine incident matrix first. So first here possible number of nodes. Incident matrix means possible number of nodes. How many number of nodes here? 1 and 2 number of nodes. So here I am representing this node with A and this node I am representing with B. And possible number of branches here 1, 2 and 3 branches. Now here the incident matrix size is 2 by 3, number of nodes cross number of branches. So here, so these are the how many branches here? These are the branches. These are the nodes. The matrix size is 2 cross 3. So here 2 indicates number of nodes and 3 indicates number of branches. 2 indicates number of branches. Now here what are the branches here? 1, 2 and 3. And here what are the nodes? A and B. Here this node is represented with A and this node is represented with B. Now here we know this one, A element Aij equals to this one +1 and -1 and 0. And here at node I, if that branch is branch orientation is away from the node, means living away from the node, means that is +1, and is entering to the node means that is -1. If that branch is not associated with the node, is that value is 0. Now fill these three values. A incident matrix elements only 1, -1 and 0. Now here the first element Aij, A1, this is first row, first column Aij. Now here first node is A and 1. For A node, from the A node, so one branch is living away from the node A. So living away from the node means towards the node. Towards the node means, so living away from the node means you take this value is +1, and 2 branches living away from the node. 2 branches living away from the node. So +1 node A, from the node A 2 branches living away from the node, and 3 branches also living away from the node +1. Next, from the B branch is entering towards the node. So entering towards the node, that means this is -1. 1 branch is entering towards the node and 2 branches entering towards the node and 3 branches entering towards the node, -1, -1. So now here the matrix size is for A matrix is +1, +1, +1 and -1, -1 and -1. Algebraic sum of any column in a incident matrix must be 0, this value. If you add all these column elements, so that value should be 0, that must be 0 plus 1 minus 1 0 0. So that property, first property is satisfied. This is first problem. And second problem, for a given graph, determine incident matrix. So possible number of nodes here. So here 1, this is the node, and this is the node, this one is the node, and this is 2 or more branches connected to one point. And here this node is I am representing with A, and this node I am representing with B, and this node I am representing with C, and this is the D. Now here branches, what are the branch? 1, 2, 3, 4, 5 and 6. So the matrix size here, this one. So first I will write, these are the branches here, and these are the nodes. Now here I will write incident matrix with represented with capital A. The elements are always 0 or 1. So here Aij equals to plus 1 and minus 1 and 0 plus 1 is the branch is oriented away from the, living away from the node means that is plus 1, and entering towards the node means that is minus 1, and 0 indicates the branch is not associated with the branch is known as the, that value is 0. And here these are the branches and these are the nodes. Possible number of nodes, here nodes I am represented with A, B, C and D. What are the branches here? 1, 2, 3, 4, 5 and 6. So 6 number of branches, and here. So this matrix size, incident matrix size is 4 cross 6. So 4 number of nodes and 6 number of branches. So here elements, elements are plus 1, minus 1 and 0. Here from the A branch, so one branch is entering towards the node. So one branch orientation is entering towards the node means, so entering towards the node means enter. That means this is the minus 1. And here 2 branches living away from the node A. So that is plus 1. And 3 branch, 4 branch and 6 branch. So 3 is not associated with branch node A, and 3 branch is not associated with node A, and 4 branch is also not associated with node A. This value is 0, and 6 branch is not associated with this one, 0. Next, 5 branch is living away from the node means you can take this one as a plus 1. Next, similarly, second step, for all nodes, repeat the same first step B for B. So what are the not associated branches for this particular B node? 1, 3 and 5. So 1 value is 0, and 3 value is 0, and 5 value is 0. So 1, 3, 5 branches are not associated with node B. 1, 3, 5 branches not associated with node B. You can take this value as my 0, and here this 2 branches entering towards the branch B, and 6 branch is entering towards the branch B, and 4 branch is entering towards the branch. So entering means that is minus 1. This is minus 1, this is minus 1, and this one is the minus 1. All 2, 4 and 6 branches are entering. So that values are minus. Next, similarly for C branch node is taken here. If you take C branch, so that C branch, C node, for the C node are not associated branches are 1, 2 and 4. So 1 value is 0, 2 value is 0 and 4 value is 0. So these are not associated with C branch 1, 4, 2, and 3 is three branch orientation towards the C. So this one towards the C means -1, and 6 branch orientation is away from the living away from the node, that is the +1, and 5 branch is entering, so that is the -1. Next case, for the D branch not associated elements 2, 6 and 5. 2 value is 0, 6 value is 0 and 5 value is 0. Now 1, 4, 3. So 1 is living away from the node and 4 is living away from the node and 3 is living away from the node. So living away from the node means that is +1. So 1 is +1, 3 is +1 and 4 is +1. Now here you can write this matrix -1, +1, 0, 0, 1, +1, 0, 0, -1, 0, -1, 0, -1, 0, 0, -1, 0, -1, +1, +1, 0, +1, +1, 0, 0. Now, first property, algebraic sum of in any column must be 0. In the incident matrix, algebraic sum of this algebraic -1 + 0 + 0, that value is 0. And +1 -1 0 0, this value is 0, and 0 0 -1 +1, this value is 0, and 0 plus -1 plus 0 plus this value is 0, and this +1 0 and -1 and 0, that value is 0, and 0 -1 +1, this value is 0. So algebraic sum of in any column must be 0. That is satisfied for this particular graph, incident matrix. Now next problem. For a given graph, determine the incident matrix. Same 6 number of branches and 4 number of nodes. Here A is a one node and B is the second node and C is the third node and fourth is the D is the fourth node. Here these are the same, here same thing you need to follow. Branches and nodes, A branch, B branch, C branch and D branch, A node, B node, C node and D node. And here these are the branches 1, 2, 3, 4, 5, 6. You can represent with naming also A, B, C, D, E, F, and here 1, 2, 3 also you can represent as your wish. And here you can write here A branch. A branch not associated elements are 5, 3 and 6. So A branch not associated 5. 5 is not associated with A and 6 is not associated with A and 3 is not associated with A. So these values are 0. So now here one branch is entering, that means minus, +1, -1 and 0. This is entering and this one is the living and this is not associated. So not associated values are 0. This is entering and here fourth branch is also not associated. Fourth branch is associated with B and D only and 2 is living away from the node and this is a +1. Now for B node, only 3 branches are associated. 2, 6 and 4, 1, 3, 5 are 0, not associated. 1, 3 and 5 are 0 and 2, 6 and 4 are entering towards the node. that orientation, that branch orientation towards the node. So that means that is -1, -1 and 1, 2, 4 and 6, 2, 4 and 6 are entering towards the node. And next C branch, say C node, not branch. For the C node, so 2, 1, 2 and 4, 1, 0, 2, 0 and 4. So these are the branches not associated with C node 1, 2, 4. So that values, that elements in the matrix is 0, and here 6 branch is living away from the node means +1, and 3 branch is entering to the node means that is -1, and 5 branch is living away from the node means that is +1. Now for the D matrix, D node, for this D node, node A, node B, node C completed, next node D. So not associated elements here 2 and 6, this values 2 and 6 values 0, and 1, 4, 3 elements are living away from the node means +1, 1, 4 and 3. So these are the living, and 5 branches entering, so that value is 0. Now check the property of incident matrix. So +1, +0, +0 and -1, this algebraic summation is 0, and +1, -1, 0 and 0, this value is 0, and 0, 0, -1 and +1, this value is 0, and 0, -1, 0, +1, this value is 0, and 0, 0, +1, -1, this value is 0, 0, -1, +1, 0, this value is 0. So algebraic sum of in any column is 0. Algebraic sum of in any column in the incident matrix, that value is 0. Here A and this one. So here 4 cross 6, that equals -1, +1, 0, 0, 0, 0. And next here 0, -1, 0, -1 and 0, -1. And here 0, 0, -1, 0, +1, +1 and +1, 0, +1, +1, -1, 0. So this is the incident matrix for this particular graph. Now next problem. This is unoriented graph. Unoriented graph means no direction. First convert into the directed graph. Directed means oriented graph. So now here for this possible number of nodes. Here possible number of nodes 1, A, B, C and D. Total 4 number of nodes. 4 number of nodes N equals to and B equals to 1, 1, 2, 3, 4, 5 and 6. If you assign the orientation directions, and here these are the directions 1, 2. Now for this particular graph, determine the incident matrix. Now here these are the branches, these are the nodes. Now the branches are here 1, 2, 3, 4, 5 and 6, and nodes are A, B, C and D. Now here for this graph, so first here A node, A from A to B it is flowing, and A branch, A node not associated elements are 2, 6 and 4. 2 value, 6 value and 4 values 0. 1 is leaving away from the node means +1, and 5 is entering to the node means -1, and 3 is entering to the node means minus 1. And next, B branch, B not associated elements are 5, 6 and 3. 0, 0 and 0. And associated elements are 1, 4, 2, 1 is entering and 4 is entering means that means minus 1 and 2 is leaving away from the node means plus 1. And for C node, 2, 4, 2, 3, 6 are associated elements, 1, 4, 5 are 0. 1, 4, 5 are 0 and 2 is entering and 6 is entering means that is minus 1 and 3 is leaving away from the node means that is plus 1. And D node, for this D node, so 1, 2, 3 are 0, not associated and 4, 5, 6 are leaving away from the node means plus 1 and plus 1 and plus 1. If you do the algebraic summation for each column, that summation is 0. So the property is satisfied. So number of branches are 6. So these are the elements for the incident matrix. Now, next problem. This is also unoriented graph. So possible number of nodes here, n cross b means here A node, B node, C node, D node and E node. So total number of nodes are 5 here and branches 1, 2, 3, 4, 5, 6, 7, 8. So 8 branches. Next, the orientation 1, this direction, this direction, this direction. So these are the directions. Now it is a directed graph. Now here the matrix, here first these are the branches, these are the nodes A, B, C, D and E. These are the nodes and the branches 1, 2, 3, 4, 5, 6, 7 and 8. Now here for A node, one branch is entering, that means minus 1, 2 branches leaving away from the node, that means plus 1 and 5 branches entering, that is minus 1. Remaining all elements 6, 3, 4, 8 and 7 is also not associated. So that values are 0. And B branch, so B node, only 2, 6, 3 are associated. Remaining all elements are 0. 1, 5, 8, 7, 4. 1, 5, 8, 7, 4 are 0. And 2 is entering to the node means minus 1 and 6 is entering to the node means minus 1 and 3 is leaving away from the node means plus 1. And for the C node, the not associated elements are 1 is 0, 5 is 0 and 2 is 0. And next 8 is also 0 and 3 element is entering to the node means that means minus 1. 4th element is leaving away from the node means that is plus 1. And 7th element is leaving away from the node, entering to the node means minus 1, 6 is not associated. Next for the D node, 1, 4, 8 are associated elements. Remaining all elements are not associated. 1 is leaving away from the node means plus 1 and 8 is entering to the node means that is minus 1 and 4th is entering to the node means that is minus 1. Remaining all elements are 0. Next, E node 1, 2, 3, 4 are not associated and 5, 6, 7, 8 are leaving away from the node plus 1. Now the arithmetic algebraic summation perform. So this value summation 0, this summation must be 0, this summation is 0, this summation is 0, this algebraic summation is 0, this algebraic summation is 0, this algebraic summation is 0, and this algebraic summation is 0. So this value is complete row. So algebraic summation of in any column is 0. Now for this graph, determine the incident matrix. So first, branches and nodes, A node, B node and C node, 1, 2, 3, 4, 5 nodes. So this is not required. 5 branches only, A, B, C, and this is the node, D node. And here from the A node, 1 and 2 are not associated. 1 and 2 not associated. 3, 4, 5 are entering to the node, that means -1. And here for B node, only 3 and 2 are elements are associated, and 1, 4, 5 are 0. 1, 4, 5 are not associated. 2 and 3. 2 is living away from the node and 3 is living away from the node, +1 and +1. And for C node, so entering to the node and -1 is living away from the node. So 5 is -1 and 1 is living away from the node, means +1, remaining all elements are 0. And for the D node, 3 and 5 are 0, not associated. So 1 is entering and 2 is entering, means that is -1. And next 4 is living away from the node, means that is +1. Same thing if you perform the algebraic summation operation, that means this is 0, 0, 0, 0. Algebraic sum of all elements in a network, in any column, that means that should be 0. Here 4 number of nodes and 5 number of branches. The order of the matrix is 4 by 5. These are the elements in the incident matrix. Next, determine the incident matrix for this network graph. Here possible number of nodes: 1, A, B, C, D and E. So 5 number of nodes cross and branches: 1, 2, 3, 4, 5 and 6, 7, 8. 8 number of branches. 8 number of branches. So these are the branches. These are the nodes: 1, 2, 3, 4, 5, 6, 7 and 8. And these are the nodes A, B, C and D, E. Now here A branch. For A branch, 1 is entering -1, 4 is living away from the node +1 and 7 is living away from the node and +1. Remaining all elements are 0. Next, for the B node, 2, 4, 5 are entering. Entering means -1. 2, 4, 5 are -1. Remaining all elements are not associated with node B, so that values are 0. Next, 7 is entering towards the C, -1, and 5 is living away from the node, and that is +1, and 3 is entering to the node, -1. Remaining all elements are 0, not associated. Next, for the D node, only 3 elements are associated, 2 elements, 6 is entering and 8 is entering. -1 and -1, remaining all elements are 0. Next, E node 4 is 0 and 5 is 0, 6 is 0 and 7 is 0, not associated. And 1, 2, 3, 8 are living away from the node. So +1, +1, +1, and this 8 is also away from the node, +1. So now here if you perform algebraic summation, this is 0, 0, 0, 0, 0, 0. Add this, all these 5 elements column, so that value is 0. Algebraic sum of in any column, that must be, that value is 0. Next one, last problem. So determine the incident matrix for a given network graph. So same thing here, total 5 number of nodes, 1, 2, 3, 4 and 5. So A, that represented with the first node is A, B, C and D, and branches are 1, 2, 3, 4, 5, 6, 7 and 8. Now here these are the branches, these are the nodes 1, 2, 3, 4, 5, 6, 7, 8, A, B, C, D, E. Now here one branch and is entering -1, 4 branch is leaving +1 and 7 branch is leaving +1, remaining all elements are not associated with node A. And for B node, 2, 4, 5 are entering towards the node. 2, 4 and 5 are entering towards the node, that value is -1 and remaining all elements are 0. And next, C node, 1 is 0, not associated, 2 is 0, not associated, and 8 is 0, not associated, 7 is 0, not associated, only 5 is living away from the node +1, and 6 is living away from the node +1, and 4 is also not associated, and 3 is entering to the node, means that is +1. And for this particular D node, 7 is entering, so that is -1, and this 8 is entering, that is -1, and this 6 is entering, that is -1. Remaining all elements in that row are 0, that branches are not associated with D. And for E branch, here not associated, 4, 5, 6 and 7 are not associated, only 1, 2, 3, all elements are living away from the node, +1, +1, +1, and this is the +1. Now summation, this summation is 0, 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 and this summation is 0, +1 +0 +0 -1 0, and 0 +0 +0 plus -1 +0, this value. Algebraic sum of in any column, that must be 0. In case of this one, this matrix size is 5 by 5 cross 5. This matrix size is 5 cross S order. Now, I hope all these problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.